Okay, so listen to this. We're going to dive into AI that can see, well, kind of. We're talking about those multimodal large language models,
Yeah.
uh, MLLMs, if you want to be fancy. And you sent over some research on these MLLMs that is seriously interesting, especially the part about hallucination.
Yeah, it's a little like, when your brain plays tricks on you, like you think you see something, but it's not really there. It's like that, but for AI and with pictures.
So instead of like seeing a ghost in a dark room, the AI might think it sees a car in a photo, but it's just a tree or something.
You got it. Exactly that. And while a phantom car might not seem like a big deal, these hallucinations could be a real problem, especially as we start using these MLLMs for things like self-driving cars.
Oh, okay. Now that you mention it, that is a little creepy. I don't want my car deciding to go through a Starbucks drive-through because it's hallucinating. But now I'm a little confused. This research says that even though they mess up like that, these MLMs can actually recognize stuff in images. So which is it? Can they see or not?
Well, that's the question, isn't it? And the thing is, it's not a simple yes or no. Think of it like this. Imagine you're trying to learn a whole new language. You might be able to pick out some words here and there, right? But to actually make a sentence that makes sense, that's a whole other thing.
So you're saying these MLLMs are kind of like babies learning to see.
In a way, yeah. They can look at a picture and tell you, yeah, that's a car, that's a tree, whatever. But understanding the whole picture, how things fit together, that's where they get tripped up.
Which explains the her phantom car thing. Okay,
Yeah.
so how do researchers even know if these MLLMs are recognizing anything at all? Can't just ask them, right?
You're right, it's not that easy. What they do is they design an experiment. Imagine showing the MLLM tons of pictures. Some have a bike in them, some don't, and each picture has a description with it.
So it's like they're teaching the AI to connect the picture to the words, kind of like when kids use flashcards.
Exactly. They train the MLLM on this massive pile of image text pairs. Then they show it totally new images, some with bikes, some without, but no descriptions this time.
Did it pass the test? Did it start writing poetry about bicycles?
Not quite poetry, but yeah, it actually got it right about 80% of the time. It could tell if a bike was in the picture or not.
80%. Okay, so it's not totally clueless.
Mm-hmm.
But then why all the hallucinations? If it can recognize a bicycle, why is it making up things that aren't there?
That is the really interesting part. The research thinks that the MLLM's language model, that's the part that actually writes out the descriptions, might be, well, overriding what it sees. And it's doing that because of what it already knows.
Hold on, back up. You mean everything it learned from all that training data?
Yep. See, these MLMs learn from huge data sets, and those data sets have all sorts of info about how the world works, common sense stuff, cultural biases, all of it. The MLLM soaks that up, and then it uses it to try and make sense of new images.
So it's like the AI is saying to itself, well, I know there's usually a Starbucks on every corner, so I'm just going to assume there's one here, even if I can't really see it.
Exactly. That's a great way to put it. And it turns out that this tendency to rely on what it thinks it knows, even if it goes against what it sees, that's a big reason why we get these hallucinations.
Wow, that's kind of freaky when you think about it. It's like we're accidentally teaching AI to make the same assumptions we do, even when they're wrong. So is there any way to fix this? Can we teach AI to, like, trust its eyes more than its brain?
That's where things get exciting. The researchers actually came up with a possible solution. They call it dynamic correction decoding. DeCo for short.
DeCo. Okay, that sounds interesting. Tell me more. How does this DeCo thing work?
Well, it's about looking at how the AI is processing information, but at different points in the process.
Okay, hold on a second. Are you saying AI has a thought process now?
You got me. But it's kind of like that, yeah. Remember how we talked about those layers in the MLLM? The early layers are dealing with the raw visual data, like just shapes and colors. And as the information moves through, it gets more abstract. Like it starts making more assumptions based on what it's learned.
So the early layers are like, oh, colors and shapes, and the later layers are like, those colors and shapes are probably a cat wearing a hat.
Exactly. And what DeCo does is it's listening in on those early layers where the visual information is strongest, and it uses that to double check the later layers.
So it's like DeCo is the AI's inner voice saying, hold on, are you sure about that cat in a hat? Look again.
Yes, you're getting it. DeCo figures out which of those early layers seem to have the best grip on the actual visual stuff, and it uses those as what we call anchor layers.
Anchor layers. Sounds important.
They are. These anchor layers are like the grounded ones, the ones that aren't letting the AI's assumptions run wild. So DeCo takes that grounded perspective and it makes something we call a correction signal, which gets combined with what those later layers are saying.
So it's not like a total override. It's more like a, hey, maybe rethink that a little.
You got it. A little nudge in the right direction. And the really cool part about DeCo is that they can adjust how strong that nudge is. There's this thing called alpha.
Alpha, is that like turning it up to 11?
Huh. I like the way you think, but no. It's more like, think of a sound mixer. You can adjust how much of each thing you hear. Same idea here. They can fine-tune how much reality check DeCo is applying, depending on what they're asking the AI to do.
Slick. So did they actually test this thing out? Did DeCo actually make the AI hallucinate less?
They did, and get this. The results were really good. They used a couple of those benchmark data sets that are made to test for hallucinations in MLLMs, like how bad is it? One's called Che-Air and the other is POPE.
Okay, those are some creative names. So how do these AII exams work?
Huh. AII exams, I like that. Well, so CHAIR, which stands for Caption Hallucination Assessment with Image Relevance, they basically show the AI a picture and say, okay, what do you see? And then they check to see if the AI starts making up stuff that's not actually there.
So if the AI starts going on about a pink elephant when there's clearly no elephant, that's a hallucination.
Exactly. And CHAIR gives the AI a score based on how many of these phantom objects it comes up with. Lower score, fewer hallucinations, meaning it's doing better at sticking to the facts.
Makes sense. What about PPE? How's that one different?
So PPE, that's polling-based object probing evaluation, it's more straightforward. Instead of open-ended descriptions, PPE is all about asking specific questions like, is there a bicycle in this picture? Or how many people are wearing hats?
So it's less about storytelling and more like, can you actually see what's right in front of you?
Exactly. And it's not just any old objects they ask about. They use 3 categories to really put the AI through its paces.
Okay, hit me with it. What are the categories?
So first, there are random objects, just like it sounds, just to see what the AI picks up on.
Yeah.
Then you've got popular objects, the kind of things that show up all the time in data sets. This is where it gets interesting because the AI's biases can really start to show.
Right, like assuming there's a coffee shop around every corner. Okay, so random, popular. What's the last one?
Adversarial. And this is where they try to really trip the AI up. These are objects that are visually similar to things that are in the image to see if the AI can tell the difference.
Like showing a picture of a car and asking if there's a truck.
Exactly. It's clever, right? They want to see if the AI will make a false positive. So to answer your earlier question, they tested DeCo on both of these, and it did great. It was better at reducing hallucinations than any of the other methods they tried.
That's really something. It's not just recognizing a bicycle. It's understanding the bigger picture, not jumping to conclusions. Are there any, real-world examples of these hallucinations, though?
Oh, yeah, absolutely. Think about something like medical imaging. People are really interested in using MLLMs to help doctors diagnose diseases from x-rays, CT scans, all of that.
Which, wow, that could be amazing. Faster, more accurate diagnoses. It could make a huge difference.
Right. But here's the thing. Imagine if the MLLM looks at a lung x-ray and thinks it sees a tumor when there's not one. Or the opposite, it misses a fracture on a bone scan.
Oh, wow. Okay, yeah, that changes things.
Yeah.
Suddenly, it's not just a funny glitch anymore. It's serious stuff.
Exactly. And that's why this research is so important. We can't just throw AI at these problems without making sure it's really up to the task.
It's like a reality check for sure. AI has potential, but we're not quite there yet. Now, the research also mentions something called MME, another benchmark. What's that about?
Oh, yeah. MME, that stands for Multimodal Model Evaluation. That one's like a bigger test, like a whole AI SAT or something.
Okay, I'm listening. What kind of subjects are on this AI SAT?
Oh, all sorts of things. They test if it can read text in an image, so like optical character recognition, if it can answer questions about what's happening in a picture, and even stuff about spatial reasoning and common sense.
Wow, it's not just about what you see, but how you understand it all, right? How did DeCo do on this one?
Really well. The MLLMs that use DeCo did better on all the MME tasks, which seems to say that fixing those hallucinations actually helps them understand and perform better overall.
That's really cool. So it's not just fixing one thing, it's helping them think more like, well, us.
Exactly. And that brings us to another really important thing, how fast it is. You could have the smartest AI in the world, but if it takes forever to do anything, it's not going to be very useful.
Especially for things like self-driving cars.
Oh.
I need my car to know what a stop sign is, like now.
Right. Luckily, though, it looks like DeCo is pretty efficient. It doesn't slow the AI down much at all, which is great news if we want to actually use this stuff in the real world.
So it works, and it's fast. Almost too good to be true. But this whole thing about AI seeing, it makes you wonder, what does it mean when AI starts experiencing the world, even a little bit, like we do?
It's a huge question, isn't it? And it's not just about the benefits. There's always the risk that it could be used in ways that are harmful or that we haven't even thought of yet.
Exactly. It's like we can't just focus on making AI better and better without thinking about the bigger picture, right?
100%. We have to make sure that AI is developed responsibly and ethically, and that's something we need to be thinking about now.
For sure. We need to be having these conversations now
Yeah.
before it's too late. It's kind of amazing when you think about it. This whole deep dive started with us talking about how AI experiences the world.
It really has been quite the journey. We started out by talking about these MLLMs, these systems trying to learn from both text and images.
And we talked about the problems they have, like these hallucinations that show us where they're still limited.
And we've seen how researchers are trying to fix those problems and make these systems more reliable, which is really important work.
It is. But I think the really big thing here is that it makes us ask some even bigger questions about how we understand the world and what it even means to be creative. Those are some deep thoughts, and I don't think there are any easy answers.
No easy answers, but they're definitely worth thinking about.
It really makes you wonder, right? Like, if AI can hallucinate, does that mean it's got something like, I don't know, imagination? What would that even mean for AI?
Whoa, now those are the big questions. And it's true, there's definitely a fuzzy line between hallucinating and imagining. Like usually we think of hallucinations as, mistakes, glitches, and then imagination is this whole creative thing.
But maybe for AI, it's not so clear cut. Maybe these glitches are showing us that they're actually starting to think outside the box, coming up with stuff that's totally new.
That's a wild thought. AI coming up with ideas we've never even thought of, new concepts, even art, stuff that goes way beyond what we trained it on.
Right. It could change, well, everything. How we design stuff, how we make scientific discoveries even. But it's not all sunshine and roses, is it?
Of course not. AI is powerful, and with great power comes great responsibility, as they say. It could be misused, or even if we're careful, there could be consequences we haven't even thought of yet. That's why this is so important. We can't just be focused on making AI smarter. We have to make sure we're developing it ethically, too. Lots to think about.
We got to have these conversations now, not after the fact. And, in a way, that's what this whole deep dive has been about, looking at these big, almost philosophical questions about how AI sees the world.
Right. It's been quite the ride. We started out talking about these MLLMs, trying to understand how they learn from both text and images.
Right, and then we dug into the problems, like those hallucinations, and how they show us the limits of what AI can really do right now.
Exactly. But we also talked about the solutions researchers are working on, like DeCo, to try to make these systems more accurate, more trustworthy, which is huge.
Huge, for sure. But I think more than anything, what we've done here is touched on these massive questions that AI brings up. Questions about knowledge and creativity and what it means to understand something. We might not have the answers, but these are things we need to keep thinking about.
Absolutely. And those are the kind of questions that keep this whole field so fascinating.
Couldn't agree more. So to everyone listening, as we go further into this world of AI, don't be afraid to ask the big questions. Keep learning, keep exploring, and keep your eyes peeled, because who knows what amazing discoveries and challenges are right around the corner.
That's what I'm talking about. The future of AI is wide open, and it's up to all of us to shape it.